Welcome to qnawire.
Okay, so we're doing chapter 34, problem 37 here. So for each of these lenses shown, we want to calculate the location of an object, or calculate the location of the image of an object that is 18 centimeters to the left. So that means we're having an image or object location of 18 centimeters, and it says the index of refraction of each of these lenses is 1.5. So to set this up, we're going to have to use the lens maker's equation. They tell us the magnitude of each of these radius of curvatures, but we'll have to figure out the sign of them, and then also use that to figure out the focal length, and thus the image distance. So to set this up, let's write out the lens maker equation here. So we have this equation here, but this is also equal to, using the thin lens equation, 1 over s plus 1 over s prime. So what we're going to do next is we're going to simplify this and solve for s prime. And what we can do is just rearrange some stuff. We'll put this 1 over s over here, subtract it off from each side, and then we'll just take the inverse. So it's not that hard. So we have s prime here equals n minus 1 times the difference in the inverse radius of curvatures, and then we're going to subtract off 1 over the object distance and take the inverse of all of that. So now that's our equation, and we know n, we know s, and we just got to figure out what R1 and R2 is for each of these lenses. Okay, so now let's go over here to these pictures I drew, and for part A we have double convex lens. It says the magnitude is 10 on the left and 15 on the right in centimeters. These are all in centimeters. So convex lenses, when you're on the left, is a positive value, and on the right is negative. And so when you're concave, it's going to be exactly the opposite of that. So for part B here, we have a convex on the left side with 10, so that's a positive. And then the right side, it says flat, so that's an infinite radius of curvature. Moving on to the third one here, we have concave on both sides. So now it's the opposite of the first case, where the first one is negative and the right side is positive. And then for part D, we finally have two concave ones. So the first one is negative, and the second one is convex, so it's also negative. Cool. So now we know R1s and R2s for each of these, so we just have to plug in to our equation right here. So for part A, let's plug that in. We have s prime, and this equals 0.5, because that's 1.5 minus 1. And then let's plug in this 1 over 10 minus 1 over negative 15. Okay, and let's subtract off the rest, 1 over the object distance, and inverse it. Cool. If we plug that in our calculator, we should see this comes out quite nicely, and we're left with 36 centimeters. Perfect. And this is a positive object distance, so that's going to be 36 centimeters to the right of the lens. Okay, so let's move on to part B. We already have all these things figured out, so we'll just plug them in. And we should see, if we plug all that in our calculator, we should get negative 180 centimeters. So now that's negative, so that means we're talking about on the left side of the lens. So 180 centimeters to the left of the lens is where the image is here. Okay, so let's do part C here now. So we have s prime equals 0.5, 1 over negative 10 minus 1 over 15 minus 1 over 18, all inversed. And let's put that on our calculator, and we should see this comes out to negative 7.2 centimeters. So again, the image is on the left side of the lens by 7.2 centimeters. Lastly, let's plug in for part D. We got 0.5 here times 1 over negative 10 minus 1 over negative 15 minus 1 over 18, all inversed. And again, we're going to get a negative number here. So this is negative 13.8 centimeters. Cool. So again, negative on the left. So all three, the B, C, and D cases all have images on the left side of the lens, while case A is going to have one on the right side of the lens.